Hello, good day, and welcome to the Tintri Live demo series. Today's session will be featuring Synchronous Replication. My name is Bill Roth, and I'm joined by Neil Glick.
Hi, Bill.
And Tomer.
Hi, Bill. Hi, everyone.
And we are part of the technical marketing team here at Tintri headquarters in Mountain View. Let's go ahead and take a look at Synchronous Replication. What is it? Well, it's a zero RPO recovery point objective for mission critical applications. All VMs in a system or at a data store level can be put into a synchronous replication service group. So you can mix and match. You don't have to do the whole VM store. You can pick a subset of the virtual machines and configure them for synchronous replication. What this allows us to do is introduce this RPO of zero. We have other solutions that will give you a recovery point objective of 1, 15. The point we're trying to make is that they can all coexist on the same Tintri VM store. The other thing that's neat about this is that we can mix and match storage. So what that means is that this can work with a T5000 all-flash series Tintri VM store and a T800 series hybrid flash Tintri VM store. It'll also work with the T600 and T500 series products as well, but you can mix and match all these different series of storage. The other important thing, and you're going to see this live in a few moments, is the configuration and manageability is carried out through something we call Tintri Global Center, and it represents a single pane of glass for monitoring, managing, and configuring one or more Tintri VM store systems.
Hey, Bill, we've got a question from the audience.
Okay, what is the question, Neil?
The question is can you explain RPO and define and what the definition is?
Yeah, so RPO, or recovery point objective, roughly defines the amount of data that you can afford to lose in the event of some kind of outage or disaster. So if we had a recovery point objective of 1 hour, that effectively means that we could lose up to an hour's worth of data and then recovery. So our recovery point would be up to an hour ago, right? When we say a recovery point objective of 0, that means there's no data loss, okay? And we'll see that in today's demonstration live. There's another thing that goes along with that, which is recovery time objective. So back in the days when we would use other backup media, and we would have to recover from tape, for instance, it could take 2 or 3 or more hours to recover. So we also have a recovery time objective of 0 with synchronous replication. Does that answer the question?
Sure does. Thank you, Bill.
Okay, the next slide, we wanted to throw some more data points at you, and the data centers can be hundreds of kilometers apart. So the distance parameter. There's also something here we wanted to point out, is that we can replicate with synchronous replication bidirectionally. So there would be 2 synchronous replication service groups going in opposite directions. Okay? The other thing we want to point out is that we recommend a redundant high bandwidth network. And this also features single-click failover. Is there another question?
There sure is, Bill. The slide says the data centers can be hundreds of kilometers apart. Is there a distance maximum that we have, or can you explain that a little more?
Yeah, what I'm going to do is ask Tomer if he can talk to that, because he's got some excellent data points that we don't have on the slide.
Yeah, so this is a really good point because it's really all about latency. And when we're saying hundreds of kilometers apart, we're really alluding to the latency that is added by the distance or the links running over hundreds of kilometers. So when we're talking about synchronous replication, we're actually writing data into 2 locations before we get back to the client and acknowledging that write operation. So it's really up to what the application, what the client is able to absorb when it comes to latency. So for some applications, it will be shorter distances with lower latency, and others would actually sustain higher latency with the VM stores being further apart.
Okay, that's great. Thanks for answering the question. Let's move ahead. What we're looking at here is a preview of what we're going to see in Tintri Global Center. So on the left, we have a really neat monitoring capability where we can look at things like the percentage of time out of sync, and we can look at physical throughput in megabytes per second. On the right side, we're actually looking at the how we would instigate or select one-click failover. So we're going to see that in the live product in just a moment. What we've got here is a neat animated slide. So this is the demo before the demo. This is explaining to you what you're going to see in the live product with the animated slide. So I'll play through this the first time, and what we can see is a client writes data through a virtual machine to the primary Tintri system, where the data gets mirrored or replicated to a secondary Tintri system. An acknowledgement comes back, and then the whole operation is acknowledged. So let's take a look at that again in case you missed it. We see the client data being written to the primary data store. It gets replicated to the secondary Tintri system, and the acknowledgement comes back to the virtual machine. Okay? Very simple. We hope this was a good visual clue in what you're going to see next. So we're going to switch now and go to the live product. Okay, here we are in the lab, and what we're looking at is the login screen for the Tintri Global Center. And let me go ahead and get us logged in. Now, this is the landing page. It's the key metrics across all Tintri VM stores being managed by this instance of TGC, or Tintri Global Center. We get a lot of interesting metrics here like IOPS, throughput, and latency. Now you can see when we hover over latency, we get a complete breakdown of all the individual factors that contribute to the latency number of, in this case, of 0.5 milliseconds, right? So we can see how much of this is coming from the network, the host, the storage, and any throttling we've applied. Now what I wanted to do was take a look at the VM stores tab, where we can see the VM stores that are being managed by Tintri Global Center.
Hey Bill, sorry to interrupt. We have a question from the audience.
What is that question?
They said that this TGC product looks really cool. Where do they get it?
Yeah, so TGC, where do they get it? Well, if you have a Tintri VM store, it comes for free out of the box. So if you're looking for it and you don't have the OVA that's used to build it, contact your Tintri sales team or your reseller sales team, and we'll make sure that you get that. Now, that's the free out-of-the-box version. There's another enhanced version that provides scale-out capabilities, okay? We're not talking about that here today, but essentially this is a free product for what you're going to see today. Does that answer the question, Neil?
Sure does. Thank you, Bill.
Sure. So back to what we're looking at. We clicked the VM Stores tab, and what we're looking at is a collection of Tintri VM stores that live in the tech marketing lab here in Mountain View. Okay. There's another tab, Virtual Machines. We'll explore a little bit before we get to the demo. And when this populates, we'll see a list of some of the virtual machines that reside in this environment. You can see down here in the lower left, we're showing 1 to 18 of 2,821 VMs. So there's a few VMs here. The next thing we wanted to do was click on service groups. So here we've got the regular service groups, and we see critical apps, Exchange headquarters, and some load testing we're executing. Another question. What's this one, Neil?
So the audience member would like to know that you brought up the service groups, Bill. What is a service group?
Yeah, it's a great question. So this service groups, what these are is they're groupings of virtual machines that we can admin as a group versus individually. So if we look at this one, Exchange HQ, it's got 5 VMs in it. If we look at Critical Apps, there's 70 VMs in that group. And things that we could do over on the right is, if we scroll down, we could administer a data protection policy against all the machines in the group, or we could administer QoS, quality of service, such as minimum and maximum IOPS for all the VMs in a particular group. So while we like to tout our ability to manage everything at a per VM level, if you had 2,800 and some odd VMs, maybe you don't want to admin that many VMs individually, and you want to throw some of them into groups that are going to share common characteristics, data protection and quality of service as examples.
That's great. Thank you, Bill.
You're welcome. Okay, so now you can see there's another sub-tab here. This one says Synchronous Replication. We'll click on it, and what we get here is a different kind of service group. These are synchronous replication service groups. We've got 2 of them. One of them is called Critical Applications, and another one is called Important Apps. Now, both of these have a primary and a secondary Tintri VM store. And if we take a look at this one called Important Apps, what we'll see here is we get some statistics, percentage of time out of sync, and we're not out of sync here in the lab. We can hover over that and get a more detailed breakdown of it, the time of day and the date and how out of sync we were. Down below that, we see VM store physical throughput in megabytes per second. Now, there's a slider here, and what we can do is we can zoom in to look at a specific time frame, or we can zoom out to look at the whole thing. So that gives us the ability to look at a more granular time slice. Now, there's some other things here that we wanted to get onto. The overview. So we get a name for the Synchronous Replication Service Group. We get an indication of VM membership in terms of the primary VM store, which is the T5060 machine. We have the sub-mount, in this case it's /Tintri/important apps, and we get the secondary Tintri VM store, a T880, right? So the primary's a T5060, the secondary's a T880. So this is an example of mixing an all-flash array and a hybrid array in the same synchronous replication service group. Okay. We also get things like a source replication IP address, a destination replication IP address, and the other thing I wanted to point out here is that there is a cluster IP address, and this is important, and we're going to look at this in more detail. Okay, setting this up is as simple as supplying these parameters and clicking create. Okay, there's no magic here. There's some optional parameters if you wanted to tweak the alert threshold if there was an error. And also you could apply QoS, or quality of service. We have not done that here. Now, if we come back, well, actually what we can do is we can look at the virtual machine that's in this synchronous replication service group, and it's called TME Important App 1. Now, what I wanted to do was hover over the primary field, and we get a complete latency breakdown of host, network, and primary storage latency. If we move down and look at the secondary, we get some of the same information, but for the secondary storage. So we're giving complete granular details of all the latency. And this comes back to the question that was asked earlier about how far can these two systems be apart. It's all about the latency. It's not really about the distance so much. Okay, now let's take a look at the environment that we're executing in. Okay, to do that, we'll come back. We want to look at our load simulator. So what this is it's representing the application that's running in this environment. And we can see that this updates about once every 2 seconds. At this point, we're going to take a look at the Tintri VM stores that are being used for the primary and secondary pieces of this synchronous replication service group. So here on the bottom, we have the T5060, which is the primary. It is actively serving both read and write IOPS. And if we look at the mirror or the secondary up at the top, this is the T880, it is only servicing write IOPS, right? So these are the mirroring write operations that are being sent synchronously to the secondary system.
And Bill, this is the read and write IOPS real time for that VM that you just showed us, right?
Yes, these are the real-time read and write IOPS for the VM we just showed you. And you can see the name of it here, TME Important App 1, and again, TME Important App 1.
Okay, thank you.
Okay, so with that, what we wanted to do was we wanted to come back to Tintri Global Center and actually do a failover. So here we are with important apps. What we'll do is we'll click failover. We get a confirmation message, we'll click OK. Now, while that's happening, we wanted to come back and take a look at the app that's executing. So here we can see it continually updates at the exact same frequency. There's no difference noticed because this is transparent failover. In fact, VMware doesn't even see any activity with regard to the failover. We'll come back at this point, and we wanted to take a look at the two Tintri VM store displays. Now, what we see here is real interesting. All of a sudden, the one on the top, the T880, which was the secondary servicing read IOPS only, is now servicing read and write IOPS. The new secondary, which was the primary, is now servicing only write IOPS. It's receiving the mirror updates. Okay, let's come back and look at Tintri Global Center again. We can confirm that the failover has occurred, and we'll come back and we'll look at important ops. And we'll come back to the overview section after the metrics update. There we go. And we can see that the primary VM store is now the 880. The secondary is the 5060. And again, we wanted to call out this cluster IP address for the data store. Okay? So with that, what we wanted to do at this point was come back and review what we just saw. We'll go ahead back to our PowerPoint deck, and this slide and the next couple slides kind of define for us what we just saw. So here's the way we started with Tintri VM Store A on the left acting as primary, servicing reads, writes, mirroring, and receiving acknowledgments back from the mirror activity over the network. We took a look at the latency being introduced by the primary Tintri VM store, and the latency is recorded on the secondary Tintri VM store. We took a detailed look at that, and one of the things we wanted to call out here was that the latency is very low as introduced by the secondary storage, and that's because as soon as the data updates hit the primary, we immediately begin mirroring that data over to the secondary. We don't wait for it to get all the way written to media on the primary. At that point, we called out the cluster IP owner, and the cluster IP owner is always with the primary Tintri VM store. We went ahead and we did a failover. Note that the primary shifted to Tintri VM Store B, and it also became the cluster IP owner. Remember, the cluster IP owner always stays with the primary system in the Synchronous Replication Service Group. And this is why it's transparent to both VMware and the application running in one or more VMs. Okay, wanted to call out some things here, and one of them was, we had a question early on Tintri Global Center. And if you come here to YouTube and you search on Tintri Space Tech and you look at the videos, you can see a couple representative videos here, a one-to-many replication demo and an all-flash array capacity expansion demo. If you go to the live site, you can also find Tintri Global Center demos, which we think you'll find very informative. Now, the next thing we wanted to call out was the ability to run some of your own self-service demonstrations or explorations in an environment hosted by Tintri. It's called explore.tintri.com. That's also the URL you would enter to get to this facility. What it does is it lets you learn about some of the Tintri features in our environment versus experimenting in your own production environment. Okay, so again, that's explore.tintri.com. And with that, we'd like to thank everybody, and we hope this was an informative and brief demonstration. Thank you, Neil. Thank you, Tomer.
Thank you, Bill.
Thank you.
Okay, thanks everyone. Bye.